Hi guys, today we're going to do section 8.4 day 1, and I want you to think back to what we did last week. We learned about two very special right triangles. The first one was called a 45-45-90, and the reason was because it had one 90-degree angle and two 45-degree angles. And what we learned is that if it has two angles that are congruent, it's also going to have two sides that are congruent. So whatever this leg is, this leg would be the same. And the hypotenuse would have a ratio of that side length times square root 2. So whatever the leg is, you'd multiply by root 2 to get the hypotenuse. We also learned about the 30-60-90 triangle. And in the 30-60-90 triangle, we have angles that are 30 degrees, 60 degrees, and 90 degrees. And whatever the short leg is, the one opposite of the 30-degree angle, this is your short leg, whatever that is, the hypotenuse was always twice as much. So the hypotenuse was double the short leg, and the longer leg was a multiple of root 3. So you took the length of the short leg and you multiplied by root 3 to get the long leg. Now imagine that somebody figured out these proportions, right? And we could, if we wanted to, continue learning about more 90-degree triangles and their proportions. So here we're given two triangles. They are similar by angle. They have two angles that are congruent to each other. The third angles would both have to be 70 degrees because, of course, the angles in every triangle have to add up to 180 degrees total. But what happens is, because they are similar triangles, their side lengths will always have the same proportions. Now, we memorized proportions for 45-45-90 triangles, and we memorized proportions for 30-60-90 triangles. Can you imagine memorizing all the different 90-degree triangle ratios? For instance, could you imagine now we have to memorize what are the ratios of the sides in a 20-70-90 triangle, or a 21-69-90 triangle, or a 22-68-90 triangle, and so on and so on. Memorizing all those would be impossible. It'd be a headache, right? And in fact, somebody did. In fact, back in the day, like around 2,000 years ago, there were several Greek philosophers and mathematicians that sat down and figured out the ratios of the lengths of the sides and the hypotenuses in right triangles. And this was the beginning of something called trigonometry. And trigonometry is the study of triangle measures. And that's what we're going to start today, is we're going to learn some very, very basic trigonometry. And basically, we're going to study how the ratios of the different sides of right triangles compare. However, we memorized the ratios for the 45-45-90 and the 30-60-90 triangles. We are not going to be memorizing any more ratios. We're going to have our calculators help us out, because if you turn to the next slide, so what happened is some people started figuring out these different ratios and they wrote them down, and this was the beginning of trigonometry. Now, trigon means triangle, and metron means measure. So trigonometry is really the study of triangle measures. Today in geometry, you're going to just touch on the very beginnings of how trigonometry works. In a couple of years, you'll have a class for a whole trimester called trigonometry, where you'll learn a lot more. But today we're just going to work with right triangles, and we're going to talk about the lengths of the sides and how they compare to each other. So as you can see here, we have a 24-90 triangle and another bigger 24-90 triangle. But if you take the ratio of their short leg to their hypotenuse, we get the same answers. That's going to happen whenever you have similar triangles. And so somebody, like I said, a group of monks wrote down these different ratios. So you can look on this chart here and see all the different ratios of the sides that people wrote down. Here's one example you might recognize. In a 30-60-90 triangle, the short leg is 0.5 compared to the hypotenuse, for instance. So remember, the short leg was always half as much as the hypotenuse. So they wrote these down, and they gave the ratios names. I don't know if you can read these up here, but there's some names: sine, cosine, and tangent, and that's what we're going to work with today. So The three trigonomic ratios that we're going to study, the first one is called sine. Sine is going to compare an opposite side to a hypotenuse. Cosine is our second ratio. The cosines are going to compare an adjacent side to a hypotenuse. And our third ratio is tangent. And tangents are going to compare opposite sides to an adjacent side. So the first thing we have to figure out is what in the world is an opposite side, a hypotenuse, and an adjacent side? Well, we're going to start with angle A. You can see right here they want us to find the sine of A. So that means go to angle A, and sine is opposite over hypotenuse. So opposite of A means across from. Opposite of angle A is side A. So we're going to put an A on the top of the fraction. And then it says over hypotenuse, and you can see hypotenuse is C. So the sine of angle A would be A over C. That would be its ratio. Cosine is adjacent over hypotenuse. Now, the adjacent side is going to be a side that touches the angle. So we're going to find the cosine of A, and I need the adjacent side to angle A. And so this right here would be the adjacent side. Technically, the hypotenuse is also adjacent to angle A because they both touch angle A. But since C is already the hypotenuse, we don't call that the adjacent side. We call the other side that touches the angle the adjacent side. So if I was going to find the cosine of A and I had to do the adjacent over the hypotenuse, it's going to be side B over side C. Tangent is opposite over adjacent. So if I want the tangent of A, I take the side opposite of A, which is little a, over the adjacent side, which we talked about is B. Okay, let's try some more. Let's use the same picture, but let's work from angle B. So let's find the sine of B. Now I go to angle B in my picture. Remember, sine is opposite over hypotenuse. So what's opposite of angle B? Well, it's side B or little b. And then it's over hypotenuse, and the hypotenuse is still C. So it's going to be over C. Let's find the cosine of B. The cosine of B is going to be the ratio of the adjacent side to the hypotenuse. We have to figure out what side is adjacent to angle B. So in this case, this side touches angle B and this side touches angle B. This side is already the hypotenuse, so A would be considered the adjacent side to angle B. So it's going to be A over C. And if we wanted to find the tangent of B, remember tangent is opposite over adjacent. So if we're working with angle B, we have to find the side that's opposite, which is B, over adjacent, which is A. Okay, so let's practice this with some real numbers. Let's find the sine of J. So you go to angle J, and you have to remember that sine is opposite over hypotenuse. And so opposite of J is 5. Hypotenuse is 13. So the sine of J would be 5 over 13. Let's go to part B. Let's find the cosine of J. Cosine is adjacent over hypotenuse. So the adjacent side to angle J is right here. It's 12. 13 is also adjacent, but it's already considered to be the hypotenuse. So 12 would be the side that we call adjacent to J. So cosine is going to be 12 over 13 because 13 is the hypotenuse. Tangent, part C. So tangent of J, tangent is opposite over adjacent. So opposite of J, remember it's across from it, so that's 5. And adjacent is 12. Now notice they say express each trig ratio as a fraction and a decimal to the nearest hundredth. So technically you should also write these as decimals. So 5/13, if you divide that in your calculator, it's approximately 0.38. 12/13, if you punch that in your calculator, it's approximately 0.92. And 5/12 is 0.42. Okay, take a second, and I want you guys to try to do sine K, cosine K, and tangent K. Go ahead and pause the video and come back. If you did it correctly, the sine of k should be 12 over 13, which is 0.92. Cosine k should be 5 over 13, which is 0.38. And tangent k should be 12 over 5, which is 2.4. So you might be thinking, where in real life would we use this? Well, here's an example. Let's say you're in aerobics class. Let's say you're in Miss Amy's class, and she sets the incline on the treadmill to 7 degrees because you're in pretty good shape. The walking distance is 5 feet long. Approximately how many inches did the trainer, or Miss Amy, raise the treadmill from the floor? Now, we can use sine, cosine, and tangent to solve this. What you do is you look at your angle that's not 90 degrees. In this case, we look at the 7-degree angle. Two sides have writing on them. The first side is, well, you can start with either side really, but y, for instance, is opposite of our angle. Never use the 90, always use the other angle. In this case, we're using the 7, and y is opposite of the 7. The 5 is the hypotenuse of the triangle. Now I want you to think about sine, cosine, and tangent. I'm going to show you a little shortcut. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You could pronounce this SOHCAHTOA. You're going to pick the trig ratio that has the two sides that you need. For instance, we have opposite and hypotenuse, O and H. Right here, you can see sine has O and H. So we're going to pick sine. So we're going to go sine of 7 degrees equals opposite, which is y, over hypotenuse, which is 5. Now, cool, we have an equation set up that we can solve for y. All you have to do is multiply both sides by 5, or you can think of it as 5 over 1, and then type this into your calculator. So you're going to go on your calculator and you're going to type in 5 sine 7. You'll see those sine, cosine, and tangent buttons in the middle of your calculator there. If you type it in and it's correct, you should get about 0.609. And this is technically going to be in feet, so we're going to have to convert this. But first, try typing it in and see if you get 0.609. If you're not, your calculator may not be in the correct mode. Make sure that the mode on your calculator is in degrees, and then try it again. Pause the video if you need to mess around with that. All right, last but not least, we're going to convert this into inches, so we're just going to multiply by 12. 0.609 times 12 ends up being 7.31 inches. And that is how far Miss Amy raised the treadmill. Let's try this again. So you start by looking at your angle that's not 90. In this case, we have 25. Two sides have writing. One of the sides is opposite of our angle, and the other side is the 18. Is the 18 the adjacent side or the hypotenuse? Well, it's not the hypotenuse because that's over here. It's the adjacent side. So the two sides that we're working with are opposite and adjacent. And so think about SOHCAHTOA. I'm going to write it down here. SOHCAHTOA. Pick the one that has the O and the A. TOA. T stands for tangent, so our trig ratio that we're going to use is tangent. We always follow the word with the angle, so tangent of 25 equals opposite over adjacent. The middle letter comes first on top, the last letter goes on the bottom. How do you solve this for x? Multiply both sides by 18. These cancel out. Type it in your calculator, 18 tan 25. You should get x is about 8.4. They don't have any labels, so we don't have to worry about labels in this case. Let's try another one. The bottom of a handicap ramp is 15 feet from the entrance of the building. If the angle of the ramp is 4.8 degrees, about how high up does the ramp rise off the ground? We want to figure out this side. How high up is that ramp? Start with the angle that's not 90. In this case, it's 4.8. One of the sides we are working with is opposite of that angle. The other side is the 15 feet. So you have to decide, is the 15 adjacent or hypotenuse? In this case, it is the adjacent side. Think about SOHCAHTOA and choose the ratio that has the O and the A. TOA has the O and the A. So we're going to do tangent of 4.8 degrees equals opposite over adjacent. Multiply both sides by 15. Type it in your calculator. And x should turn out to be, I'll pause for a second so you can type it in. Should end up being 1.26 feet off the ground. All right, we have one left. Go ahead and pause now and see if you can do this one on your own. Your angle is 15, x is the opposite, 12 is the hypotenuse. Think about SOHCAHTOA and choose the one that has the O and the H. O and H go with SO, and S stands for sine. So sine of 15 equals x over 12. Notice we don't say sin. Even though it's abbreviated, we still say sine. Multiply both sides by 12. Type it in your calculator, 12 times sine 15, and your answer should be 3.11. There's no label, so you can be done. All right, last but not least, let's try this one. This one's kind of interesting. Let's find the sine of L. Now remember, SOHCAHTOA, sine is opposite over adjacent. So if I want the sine of L, here's L, opposite is 2 root 3. Oops. I'm just going to erase this. Sine of L. So opposite is 2 root 3 over hypotenuse, and the hypotenuse is 2 root 15. Now this is kind of interesting. First of all, the 2's can cancel. And then second of all, you can rewrite the bottom to be root 3 times root 5, because 15 is 3 times 5, and these cancel. So really, the sine of L is 1 over root 5. However, we learned, can you leave root 5 on the bottom of a fraction? The answer is no. You have to rationalize the denominator. And so you end up with root 5 over root 25, but the square root of 25 is 5. So root 5 over 5 would be the sine of L. Let's try cosine. So cosine L. Cosine is adjacent over hypotenuse. Adjacent to L, well, technically both of these two sides touch L, but 4 root 3 is the adjacent side, because 2 root 15 is the hypotenuse. So we're going to have adjacent, which is 4 root 3, over hypotenuse, which is 2 root 15. So again, you can cancel these out and change it to a 2, because 4 divided by 2. You have root 3 on top. On bottom, you have root 3 times root 5, because that multiplies to be 15. These cancel, so you really have 2 over root 5. But you can't leave that root on the bottom. And so multiply by root 5 in the numerator and denominator. You get 2 root 5 over root 25, which is 5. All right, let's do one last one. Let's try the tangent of L. Tangent is opposite over adjacent. So opposite of L, remember, is across from it. So it's the 2 root 3. Tangent is the hypotenuse, opposite over adjacent. Adjacent is 4 root 3. This is nice. The root 3's cancel, and we're left with 2 over 4, which reduces to 1/2. That's it for today. Good luck. Try 8.4 day 1 homework. If you have any questions, don't be shy. Schoology, message me. I can help you out. Talk to you later.